Hi, this is our project title Broadly Defined Engineering Problem 3-Phase AC Motor Starter for Reverse Star Delta Integrated with Human Machine Interface. We are from Group 6, me and Firdaus. Our subject was a PLC Programming and Application Laboratory. So, our tutor is Miss Sumaya and Encik Muhammad Shah. So now we're going to look about our introduction. Our introduction is the Integrated Design Project (IDP). It's a comprehensive and cooperative initiative that combines multiple disciplines and expertise to address challenging design issues. It provides a platform for students to apply their knowledge, skills, and creativity to develop innovative solutions for real-world problems. This project focuses on the design and implementation of the three-phase AC motor starter capable of operating in forward, reverse, and star data configuration. The system will be controlled using programmable logic control (PLC) and integrated with the human machine interface (HMI) for seamless operation and monitoring. A star delta starter is widely used for starting three-phase induction motors due to its ability to reduce starting current without external devices. During the startup, motor windings are connected in star configuration to the limit in rush current. Once the motor achieves approximately 80% of its rated speed, the connection switches to the delta configuration for a normal operation. So our objective was to develop skills in operating and programming fundamental PLC system for controlling a three-phase AC motor starter in forward reverse style data configuration, to identify, test and troubleshoot PLC programming and wiring errors to effectively ensuring system functionality, to explore more and understand various power system components, motor starting methods and analyze their theoretical and practical performance.
So this is for the design statement. The induction motor starts when the forward or reverse push button is pressed. Pressing the forward button starts the motor in the start configuration with a green lamp, AC green lamp indicating the forward motion. After 10 seconds, the timer switches the motor to delta configuration for a full load operation, lighting the 24-volt DC green lamp. The motor continues running until the stop push button is pressed. For the reverse operation, the yellow lamp lights up. Interlock prevents the simultaneous star or delta or direction changes. A thermal overload relay trips on overload, isolating power and lighting up the red lamp. So this is our experiment setup. In this trainer, we have a forward push button which addressed as 0.00 for input, reverse push button 0.01 for input, and stop push button for an address as 0.002. And then we also have here we have PLC OM1 CP2E, green DC lamp, which is addressed same with delta configuration, delta contactor, and be addressed as 107. And also we have four relays for this experimental setup. We also have forward contactor, which is addressed as 100.00. Reverse contactor, we have 100.01, and star contactor we address as 100 and 100.05. And then lastly, we have a green AC lamp, which is will address same with the forward contactor. And also we have a yellow AC lamp that will address same with reverse motor. When we press the push button, it will energize the diffuse, and the diffuse is addressed as IR1, and then contact IR1 will energize the set that been addressed as IR2, and then IR2 will make sure the motor will move forward. At the same time, it will trigger the timer, start contactor, and then the DC. Then green lamp AC will also energize in this circuit. As a previous video, the timer will count down for 10 seconds, and after 10 seconds, the contact timer, which is T100, will energize the IR5 and make sure the IR5 to cut off the star contactor at the previous rung. At the same time, in the in the next rung, the IR5 will energize the delta contactor green DC lamp, and the system will not stop until the push button stop is being pressed, and after it's being pressed, the system will reset its own and ready for the next instruction. So right now I will talk about the reverse cycle. When we press the reverse push button, which is addressed as 0.01, it will energize the keep, which is addressed as IR3. And the IR3 will energize the reverse motor, yellow AC lamp, star contactor, and lastly it will also energize the timer 101 for 10 seconds. And then after 10 seconds, the contact timer T101 will energize the IR4. As we can remember from the previous run, the star contactor is energized, isn't it? Therefore, with the IR1, it will cut off the star contactor's current, and at the same time, it will also energize the IR4 will energize the delta contactor, and also with a DC green lamp, and the cycle will not stop until the stop push button is being pressed. From the previous video, as we can remember, we talked about the reverse cycle. So when the motor is already in the reverse state and we accidentally press the forward push button, what will happen? Actually, it will nothing happen. This is because in front of every other push button, which I mean forward push button and reverse push button, we have the interlock to make sure that motor only move in one direction only. Therefore, as we can see, when the what we call reverse push button is pressed, the anti-lock over here will not energize and will not allow the current to flow. Therefore, this is one of the safety that we've been put in our experiment. So this is our HMI interface. First, we have a forward, reverse, and stop push button as the input, and we have also timer T100, timer 101, entry and entry number. And for the output, we have forward green, which is addressed as 100.00, reverse yellow motor, which is addressed as 100.01. Star contactor will be addressed as 100.05, and delta contactor will be addressed as 100.07. As we can see, for forward green, it will address same. The AC lamp, the green AC lamp will also address as 100.00. This is because when the forward push button is being pressed, the green lamp AC will also energize. That's why it have a same address. Same goes with the reverse and yellow. Yellow is addressed as 100.01 because when the reverse push button, the motor turns to reverse direction, the yellow lamp will energize also. And then whenever delta contactor is energized, the DC green lamp will also energize. to show that the star configuration is already changed to delta configuration.
So here's our discussion and then the diagram we have here. After testing the circuit without a PLC, we encountered an issue where the both star and delta contactor deactivate at the same time and the green and yellow indicator light up at the same time too. So apart from the investigation, we discovered that the problem stemmed investigation from miscommunication during the wiring process, resulting in incorrect connection at the relay has been connected to the wrongly components. So the address, me and my teammate carefully reviewed the circuit and identified incorrectly connected wires at the relay. We then corrected the wiring according to the circuit diagram and ensured proper connection were established. Additionally, we performed a true inspection of all wires and connection, ensuring that none were loose or damaged. After making this adjustment, the star and delta contactor has been run according to the PLC programming and the programming has been adjusted for further improvement. The circuit was tested again and it performed as expected, similar to the circuit of other groups. This experience highlights the importance of clear communication and meticulous double checking during the wiring and installation process. So the conclusion is the implementation of PLC based 3-phase AC motor starter forward reverse star delta integrated with a human machine interface demonstrated efficiency and versatility of the PLC system in industrial automation. The project highlights the critical role of PLCs in simplifying complex control process, reducing wiring errors and enhancing system reliability. Through this project, student gains hands-on experience in designing, programming and troubleshooting PLC system as well as integrating HMI for improved monitoring and control. Additionally, the practical exploration of motor control, starters and power system components fosters a deeper understanding of a real-world engineering application. This project not only enhances technical skills but also underscores the importance of the precision, problem solving and teamwork in developing robust automation solutions for modern industrial challenges. Thank you.